Hello, and welcome to our short video on how to design an op-amp-based, low-side, voltage-to-current converter with a MOSFET. This schematic represents an op-amp-based voltage-to-current converter with a MOSFET. The circuit can be used to deliver a well-regulated current to a load. The current is accurately regulated by feeding back the voltage drop across a low-side current sense resistor, R3, to the op-amp. This video explains how to design this circuit using TI's TLV9062 in just a few easy steps. Please note that R1, R2, and C1 are used for stability compensation, which is beyond the scope of this video. For more information on stability, please refer to TI Precision Labs. This circuit accepts an input voltage from 0 to 2 volts and converts it to a current from 0 to 100 milliamps. It utilizes a single 5-volt supply. The equation for I/O is the transfer function of the circuit. Through negative feedback, the op-amp controls the current through the MOSFET such that it sets the voltage across R3 equal to the input voltage, VI. The first design step is to calculate the sense resistor, R3. The value of R3 is the input voltage range divided by the output current range. For this design, R3 equals 20 ohms. The next step is to check the maximum power that needs to be dissipated by the sense resistor, R3. The power is equal to the maximum input voltage squared divided by the value of R3. For this design, the maximum power dissipated by R3 is 200 milliwatts. It is important to purchase a resistor such that its power rating is not exceeded. A DC sweep of the input voltage from 0 volts to 2 volts yields an output current from 0 amps to 100 milliamps. This verifies the functionality of the circuit. Running a transient analysis with a step input signal shows the output current signal has no overshoot and ringing, which indicates that the circuit has sufficient phase margin and is stable. When designing an op-amp-based voltage-to-current converter circuit with a MOSFET, there are a few design notes to be aware of. First, be sure to use a device with rail-to-rail input or a common mode range that includes ground. Next, be sure to include R1, R2, and C1 for stability compensation. Finally, be sure to check the power dissipation of R3. Texas Instruments has many online resources to help you design circuits with op-amps. This includes reference designs and guides, educational videos, simulation and prototyping tools, support resources, and search tools. Thank you for taking the time to watch this short presentation on how to design an op-amp voltage-to-current converter with MOSFET circuit. Please visit www.ti.com for additional information and resources.